Hi everyone, this week we will see exceptions and error handling. My name is Dr. Muhammed Golech from Boğaziçi University Computer Engineering Department. By the end of this chapter, you will be able to explain how to handle errors that occur during program execution, keep the application running by managing issues gracefully and informing the user when necessary, recognize various built-in exceptions and respond to them appropriately, determine how to deal with situations where multiple exceptions may arise simultaneously, create your own custom exceptions and raise them intentionally when needed. And the try block contains code that Python attempts to run normally. The except block handles any errors that occur, preventing the program from crashing. Here we are putting code to be executed under try block and code to be executed if an error occurs under except block. Let's try to print a variable x that we forgot to define before. Then in this case, we will get an error. It is name error and it will show us name x is not defined before, right? But if I try again one more time, and if I put print x function under the try block, and if I put this explanation under except, in this case, we will get this explanation. Okay, sorry, variable x is not defined. Let's see how it works in Anaconda. Again, it is the first case. If I forget to, like x equal to 5, x equal to 10, it means define my x value. And if I print it, it will show us, okay, name x is not defined, right? And I can make it customize. I mean, this error. I want to see if I forget to define my x, and I want to see in this case this explanation instead of this error, right? It's more soft way. The try block attempts to convert the user inputs into an integer and perform a calculation. If the conversion fails, the except block runs and shows an informative error message. Okay, here we are asking user to input a number like 5, 6, 7, and after that one, in this case, if the user puts any number, it's gonna convert it to integer in the first step. Then it's gonna print if we add 5, the result will be, adding your value and 5. If I put 5 here, it's gonna return 10, right? But in case if I put some string here like X or my surname Golek, it will not calculate this value. Then it will give an error. So it will print this value. You must enter a valid integer for this calculation. For example, here we are given 5 and it will return if we add 5, the result will be 10. But if I put X, a string which we can't sum it with 5, so it will return you must enter a valid integer for this calculation. It is here. If I put 5, in case if I put x, it's gonna say you must enter a valid integer for this calculation. And built-in exceptions, Python automatically detects common errors that can occur while a program is running and generates built-in exceptions for them. Identifying these errors makes debugging easier and allows you to write more robust programs. So we will see here explanation of these errors and examples. The first one is value error. It occurs when a data type conversion fails. For example, if I try to convert my string hello to an integer, we will see this error. And type error. It occurs when an operation is performed on the wrong type. We can't sum age and 5 together, right? We can calculate this value. So it's gonna return type error and zero division error. You know that one already from first week. It occurs when a number is divided by zero. And index errors. It occurs when a non-existent index is accessed in a list. Here, our list items has 1, 2, and 3 elements, but I try to print the fifth or fourth element here. It can be 6, 7, doesn't matter. So it's gonna give index error. Okay, key error occurs when a key that is not in your dictionary. As you can see in our dictionary, we have one key and value pair, it is name. But if I try to print the key age, as my dictionary doesn't have age, it's gonna give this error. And file not error, it occurs when the file being opened doesn't exist. At the moment, I don't have this file, so it's gonna return file not found error. Attribute error, it occurs when a property or function that doesn't exist on an object is called. If you remember, we don't have this kind of function in string, that's why it's gonna give error. And name error, it occurs when an undefined variable is used. So as I don't define this variable, it's gonna give this error. And here we will see how we handle file system errors with try except. In the example, we are asking user to give the folder path address to, and once the user gives this path address, we created the folder, and after created our folder, we will print folder created successfully, right? But in some case, if it doesn't create a folder, it will print folder couldn't be created. For example, here I give this path address which I already have in my desktop. So that's why it will print folder couldn't be created because I already have that one. But if you want to show the real reason why it didn't be created right, we should give more specific explanation here. So to be able to do it, we are using these concepts. Our error was operating system error. Then you should write here s and value name. In that case, it's gonna show the exact reason. For example, it will say folder couldn't be created, and reason it is writing here. That one is Turkish because my Windows system operating system is Turkish. So you can change it with your own computer, right? Let's go and see how it works. First of all, I will show you built-in predefined exceptions. It is, as you can see, if I try to convert hello to an integer, it's gonna give value error. If I try to sum 5 and string, it's gonna return type error. If I try to divide a number with 0, it's gonna return 0 division error. And as my index has 1, 2, 3 different elements, and if I try to see the fifth element, it's gonna show us index error. And here I don't have this key inside of my dictionary, so it's gonna return key error. And I don't have this file in my desktop, so it's gonna return file not found error. And here hello, it is string, so in strings we don't have this kind of predefined functions, so it's gonna return attribute error. And the last one is I don't define any variable like that one score, so it's gonna return name score is not defined, name error, right? So here, okay, here again, same example. It will ask the user, could you please write your path address? And if I write that one, let me show you. I already have in my desktop this file. So it will say, okay, folder couldn't be created, right? But if I want to see more specific explanation why it couldn't be created, so I can write here operating system error as and error, like this. That it will, then I will edit end of the this print function here. Let's see. So it will give more specific explanation. Okay, now we can continue with multiple exceptions. So in Python, when multiple types of errors can occur, different responses can be implemented using separate excepts blocks for each exceptions, right? So this allows the program to run more safely and provides more meaningful feedback to the user, differentiating different types of errors. Okay, as you can see, we have here one try block and one and two different except blocks, right? The first one for value error and second one for zero division error. Okay, if we send, if we put here 0, it will return division by 0 is not allowed. And if I put a string which we can't be converted to integer, it will throw this error. You must enter a valid integer. Let's see. It is here. Same example. For example, if I put 2, it will just convert it to 2 integer, and 10 divided 2, it will 5, right? Let's try it. Maybe we can also put print your result is results. Let's try one more time. As you can see, it is working very well. But if I put 0, 10 divided 0, it can't be calculated. So it's gonna throw this error. It will write division by 0 is not allowed. If I put a, which is string, then in this case, it's gonna throw this error. You must enter a valid integer, right? Also, we can put all exceptions in the one lines, in the one except block, like here. But in this case, we will not be able to give more specific explanation. Instead, we just put general feedback here. And let's go and see. Okay, it is our list ABC. And I'm asking to user, could you please write an index number? In this case, I will return you the element with this index number. But if user puts out of index, like here we have 1, 2, 3, it means 0, 1, and 2 index numbers. If I put 4, it is out of index, so it's gonna throw index error. Or if I put here any numbers which can't be index number, like X, A, B, C, whatever. Let's try. Okay, I will just write H, or I will write my surname. Okay, in this case, okay, first of all, if I put 1, it will return B. It is index number 1, right? But what if I put here 3 as index number 3 out of my list 0, 1, 2, but there is no 3. So it's gonna throw this error and print this information. But if I write that one, it is even not a number, it is just string. So it's gonna prove this error and print this information, right? Now we can continue with raising exceptions. In Python, in some cases, instead of waiting for an error, we might need to create and prove our own error to clearly indicate problem. The raise statement allows the program to intentionally generate an error under certain conditions, thus gaining control. Okay, here, first of all, I just give a variable like age equal to -5, and I'm checking by using if condition here. If it is less than 0, raise an error, right? But normally it shouldn't raise an error because it is just checking what is wrong here. But I will use this value error by forcefully. Then it's gonna raise this error here. In this case, Python doesn't generate an error itself, but we logically trigger the error ourselves. So it means we forcefully prove an error. Again, one more example. Here I put one function, I define one function, and I'm checking if the score, if the number greater than 100. In this case, I will prove an error and I will write score can't exceed 100. The function intentionally stops the program when it receives a false value. Okay, let's go and see. Okay, first example, I put -5 and I say if age less than 0, then raise this error. As you can see, it gives error, right? And again, other example, if the score more than greater than 100, like 150 I sent here, then raise an error, stop the programs, and write score can't exceed 100. Okay, and we can define our own exceptions, which is not predefined in Python. In such cases, it is possible to generate more meaningful and descriptive error messages in your specific scenarios, right? To be able to do it, we have to derive from exception class. I will show you now. Okay, let's define a special exception class that doesn't accept a negative number, right? First of all, I will define my class. It is exception, my own exception. I call it negative number error. And as you can see, I derive from exception class. I put my initialize function here and str function here. And after defining my own exception here, my problem here, I create a function which returns your integers or numbers square root. If your number less than 0, it's gonna prove my spatial error I created here, right? Okay, I write my try except block here. I send -9 to my function, so it will check it if it is less than 0. As it is -9, it gonna raise this error and explanation. Okay, let's go and see how it works. Again, first of all, I define my own error here by inheriting from exception class. It is from Python. And then I define my function, which returns your number's square roots. But if your number less than 0, then it's gonna raise this error I created here. And also it will write square roots of a negative number is not allowed, right? It's our specific explanation. So I put try and except blocks here. I say, okay, my number is -9, So I will send it to my function. So it's gonna prove this error because it is -1. As you can see, operation failed and reason is coming from excepts block here. And I also put this, if you remember this skeleton, it was for explaining more specifically your error. It is coming from our own explanation. Square root of negative number is not allowed. Also in Python, to our except block, we can add else at the end of this try except block. I put it to I put this code under try block to be executed. I put this block under except block runs when an error occurs. I put this else block that runs when no error occurs. So let's continue with the example to understand much better. Okay, let's write a function that calculates the inverse of the number entered by user. I define my function here and my try, except, and else blocks here. If I write ABC here, it will give error because we can't convert to integer my string value. So it will prove that one, value error. And if I write 0, so as we can't divide 0, as we can't write 0 here, it will prove 0 division error. And if I put 4, it will successfully inverse it, and this block will run, and also else block will run. Let's see it in Anaconda. Let's go there. Okay, I define my function, and it's my try, except, and else blocks. It means multiple exceptions. If I write ABC, it's gonna prove this error, and if I write 0, it's gonna prove 0 division error. If I write 4, it's gonna run this block and this block together. And also, we can add one more block. It is finally, try, except, else, and finally. The finally section is a special block that runs at the end of a try structure. This section is executed regardless of whether the code generates an error, right? So it will work in the old case. Therefore, finally is used specially for actions such as closing files, terminating connections, or other essential operations. Okay, here again, same example. And if you remember, if I write -8 or -9, it will run the exceptions blocks, but also it will run finally block here. But pay attention, it will not run else block. Okay, let's go Anaconda and see. Okay, again, I define my function here, and I'm sending, in the first case, -8. So it's gonna prove and value error, right? It means this part. Also, it will run finally together. But if I write 16, in this case, it will run else and final 2. If you pay attention to these two examples, you'll understand what is the difference. In the first one, finally working. In the second one, finally working. But in the second one, also else working.